So what I want to do this morning with a fairly brief description is to talk about the difference between PGML files and ones that don't use PGML, that is the traditional problem approach. So PGML is this language we've been using to lay out the text of the problems. And unfortunately, most of the open problem library doesn't use this. PGML came relatively late in the game, and so a lot of the problems, all the problems written before then, of course, didn't use it, and many people didn't know about it, and they looked at older problems and copied those to make their newer problems, and so PGML has had a hard time kind of working its way into the problem library. But there are three sets of problems that use PGML, and one of them is the Portland Community College problems, and there are about 2,000 of those. This is a link to the source repository for those. Paul has hooked up the library browser to let you get at this. So let me just look at that relatively quickly here. There's a button right here for the Portland Community College problems. So there are collections here about basic algebra, basic math, and so forth. So they're doing low-level math for this. It's not calculus and above, but at least it's a large collection of problems that deal with PGML. The second one is that Paul Pearson, who is one of our presenters, who will be presenting this afternoon and later this morning, has authored problems using PGML in the subject area templates on the wiki page. So the wiki pages for this lists subject areas, so trigonometry. And in trigonometry, there are a bunch of questions requiring trig identities to be used, for example. And then here's a problem that gives the code and explanations. Well, not much explanation in this particular one. But at the top here, you'll see PGML version. So he's made PGML versions of or many of the files in the subject area. The ones that shown are still the traditional format, which we'll be talking about, but at least the PGML version is available. And again, he's linked that into this course, so the Fort Lewis problems list these ones. And if you were to look at, say, algebra problems, and we were to view these, what you would get are two versions of each of the problems, one of them in PGML and one of them not. If you look at the path names, there's ones that end in PGML are the ones that are made in PGML. So you could use, and I guess here it also says uses PGML. So you can tell these blue marked ones are the PGML ones. So you could look at those, and there's a traditional form and a PGML form. So he's done a nice job making a whole bunch of nice examples available. The last one is Montana State. They've got 27 or 30 problems there. So there are not a great deal of them in the library, but we're really hoping that you people augment the library with these as well and start to seed some of the problems so that other people will start copying your problems and make PGML show up a lot more. All right, so why do we need to understand non-PG problems? Well, it's what I just said. If we want to use existing problems as templates, you need to understand non-PGML problems and how they work so that you can translate them into PGML as you modify them. The main difference between the two is really in how the text of the problem is generated and in how the answers are tied to the blanks. In PGML, these are both done together, but in traditional problems, they're done in two separate pieces. The other set of differences is in how the text is laid out itself. The traditional begin text, end text approach, which we'll talk about, has a number of differences from PGML, and in particular how the layout is done. So the layout is controlled by using variables, as I'll show you over the next few slides. Variables control bold and italics, paragraph breaks and line breaks, indenting and centering, and so on are done by inserting special variables into the text. And some of the layout even requires commands to be executed, like bullet lists and numbered lists require commands. Some other things that you have to be worried about in the traditional form is the special characters used by HTML and TeX, so that less than signs that are outside of math mode would cause trouble. A percent sign outside of math mode would cause trouble to hard copy. So there are characters you have to worry about. PGML takes care of those for you, but the traditional form doesn't. You have to use special variables to handle those. Mathematical notation for math objects has some wrinkles you have to worry about in the traditional approach that PGML fixes. And the other thing, of course, is that the answer blanks, the answers are not tied directly to the blanks like they are in PGML. So those things are the things you have to look out for. So the format for traditional problems, should have said traditional, non-PGML problems. So the format for traditional problems is that you use begin text and end text rather than begin PGML and end PGML around your text blocks, and that you have answers following them using the ANS command. So you'll see things that say begin text and end text, and in between those things will come the text of the problem, but it's not in PGML format. It's using these other variables to do the formatting. And following them will be where the answers are. And the answers are associated to the blanks by order. So the first ants called below goes to the first answer blank, and so forth. So I want to give you two examples. This one is the PGML version of the problem that we've looked at in the past. So this is what you're familiar with, and the piece down here is the PGML. And the next one is that same problem laid out using the traditional form. And if we look at the two of these, the difference, the opening section about context and setting up the variables and so forth, that's the same. This is the part that differs, and there's an answers section that sets up the answers. So here we've got some extra mechanics going on around it with the context. I'll talk about that later. We're using LaTeX math delimiters rather than PGML math delimiters. The value of f is being inserted here. And you need to do stuff like this to make answer blanks. And again, I'm going to talk about these things in more detail later, but these are the parts that differ. Here's a paragraph break. You have to mark that specifically. Here's a line break. You have to mark that specifically as well. So all of this stuff, all of the markup tends to blur the layout of the text for you. I find PGML easier to read, but this does the same thing. So I'm going to leave that for us to look back at as we go. All right, so how does begin text, end text work, and how does it differ from begin PGML? One of the things is that begin text, end text works by performing substitutions on the text that's between these two delimiters. And it does these things in a particular order. You have to be aware of that order because the initial substitutions can contain stuff that gets substituted later. So for the order is the following. Commands are performed, and they're denoted by / curly brace, and anything inside that up to the next / curly brace is considered a Perl command to be performed, and the output of that command gets stuck into the text at that location. This is like the brackets with the @ signs in PGML. Following that is variable substitution, things that look like $sign with a variable name or $sign with curly braces around it if you need to have it directly against some other text that's not part of the name. These two are variables that get substituted. There is a substitution for TeX notation, or for algebra notation, math and algebra notation. most people don't know you can even do this, so it's not used very often, but if you see it, that's what it is. And finally, text substitution is done using the traditional LaTeX math delimiters. These are the square brackets are for display math, and the round brackets are for inline math. One of the differences between PGML and begin text, end text is that PGML does not do substitutions in this way. The results of substitutions in PGML are not further processed, whereas they are here. So that if a command produces something that has tech output in it, because the command substitution is performed first, its output will be now part of the string over which substitutions are performed, and if it included something that looked like tech, it'll get processed later. So that the order in which these things are done makes a difference. The fact that command and variable substitutions come before LaTeX means that LaTeX notation can be stored in variables or in the output of commands and still get processed. That's why PGML now includes a means of processing LaTeX after substitutions via a triple star postfix on command and variable substitution, so that this allows PGML to use the results of PG commands that were set up for the traditional problems where this happened automatically. All right, so formatting. How do you do stuff in begin text, end text? Well, you use variables for the most part. We saw in the example that par and br produce paragraph and line breaks. So if I look at that source code, here is the paragraph break, and here is the line break. These would have been done in PGML as just a blank line here where the par is, and two blanks here where the $BR is. So you'll see these variables in the begin text, end text blocks where you will see nothing in the PGML other than a blank line. If you want to do bold letters, you have to put bold and B bold and E bold for begin bold and end bold around the bold text. I'll show you that in a minute. B italic and E italic produce italics. Things like centering isn't even defined by default in traditional PG. You have to load a macro file that has B center and E center. There isn't indenting directly. There's block quote, which you can use. There is not right justification at all. So some things are harder to get. Stuff like lists and tables use commands to do those. So here is how you would do a list, a bullet list in a text, begin text, end text inside of the traditional format. Here we're saying I'm going to use a command and get its output. The command is begin list, and the kind of list we're getting is what's called an unordered list, a UL list. That is a bullet type list, not a numbered list. Lists items are indicated by $item. This puts a paragraph break between them. This starts the next item, and at the end we need to use a command to end that same list. And in fact, even this command is not part of PG. You have to load a macro file even to get that. So to get the bullet list that you would have simply used star the first item, star the second item in PGML, you have to do a lot more mechanics. These beginnings and endings have to be explicit, and your items are done with these little variables that are stuck inside of them. So I'm telling you these things not because I want you to create these, but I want you to recognize what they are in traditional problems, so when you convert that to PGML that you're going to use, you know what they are and can convert them properly. Variable substitutions inside of these, in the traditional begin text, end text, the contents of the variable, whatever it is stuck directly into the output and is no longer, nothing else gets done to it except for LaTeX processing if it contained LaTeX delimiters. No other processing gets done. So if a variable included HTML tags, for example, or text special characters, they get passed through unchanged. And that's why things like B bold and E bold can work, because they contain the proper HTML or text code to cause their actions to occur. So this is integral to the way that begin text, end text works. Things that are in variables get stuck in there directly, no further processing. So that if you had special characters inside of a variable like a % sign or something like that, it would go directly into the output and could potentially screw up the text output if you weren't careful about it. So PGML is much more pleasant about that for you. And that kind of thing works for the stuff like bbold and ebold because they're set up specially for that, but they cause math objects a little bit of trouble. So when a variable holding a math object is inserted into begin text, end text, it produces its string version, its algebra version, what a student would have typed by default, just as it does when it's inserted into any string. And this doesn't work well if the variable is substituted into math mode inside of begin text, end text, as shown below. So here we have a formula. Here we have a begin text, end text block. And inside that block, the formula is being substituted in, and it's inside of math mode. But when the substitution occurs, the math object doesn't know it's being put into a string that has math mode around it, and so it inserts its string value, and you get what looks, a text typeset this, but it looks like, a algebra string. It doesn't get formatted nicely as a fraction, as it would have if you had done this in PGML. And that's probably not what you wanted. So you have to deal with that. And one of the ways to do it is that the math objects know how to produce their text versions through the text method on them. So we could say, get a formula, and inside of begin text, end text, here we want some math, and inside that math we want F's text version, and text is a command, so we have to put it inside command substitution. So this says, and again, the order makes a difference here, because the substitution of commands is done first. F says, produce my text version, and insert that here, and now that text version is inside the math mode, and it'll get processed as the fourth step in the list of things to do. So that's why this can be made to work, but it does require extra work on your part when you're inserting the variable. You need to think about, is this in math mode, and stick the text into it, the text command into it to make that happen. And now we get a properly formatted formula here, a properly formatted fraction. Well, this idea of needing to do this is so common that there's some special methods that help make this happen. And the context can be set up to cause variables to, the math objects to insert their text versions rather than their string versions. And that's what gets done when you say context text strings as opposed to context normal strings. What that means is once the context has its text string set, whenever $F gets used to be inserted into a string, which is what's happening between begin text and end text, it will produce its text form automatically rather than its algebra format. So if you put text strings before and normal strings afterwards, then this substitution can be made directly, because instead of producing an algebra string, it will produce a text string when it's inserted there. And so you'll get that. So you will see text strings and normal strings around begin text, end text quite frequently. You can see them here in the problem we were looking at, begin text, end text, so that this $F, which is a formula from up above, will get inserted its text code rather than its algebra code. And it is these kinds of crazy things that you had to do in order to get proper output that PGML was born. It was out of, in fact, this one issue was what made me decide that PGML ought to be written, and then all of its other advantages came from that. Right, so that's text strings. The algebra notation, I mentioned this, that there's a step that produces algebra notation inside of begin text and end text, and I'll bet that Paul and Gavin don't even know you can do this. But inside of a text string, you can actually include algebra notation. So that's the inline algebra notation, and this is the display mode algebra notation. So just like you could, oops, that period should not be there. It's not in the output here. So just like you could enter a student answer in a compute call, you could use that inside here for display. One consequence of this, one thing you need to know, in PGML, the algebra notation uses this special typeset context, but in begin text, end text, it uses the current context, so it's more limited in what you can express. So that period, for example, could not have gone inside there because the period is not defined in the regular context. And also, the display mode, this display mode is actually text display mode, not just display style. So you'll see it gets a separate line and centered, and you don't have any control over that like you do in PGML. All right, so the last bit that we need to know about is how our answer blanks handled. Answer blanks are produced using an answer rule command or using the answer rule or answer array methods of a math object. So we saw that in the example that I was giving you. Here is the derivatives answer rule, and that's being used as a command because of the slash braces around this, and the result of that command is being stuck into the output, and the result of that command is the answer blank. The value that you pass to the answer rule is the width, how big an answer blank do you want. In PGML, that's controlled by how many underscores you use. Here it's controlled by a number that says how big it is. So these are both 20-character wide answer rules. The last bit that you need to know is how these answer checkers get attached to their answers. Right now, this is just a blank that has no answer checker associated with it. Even though we use df to create the blank, if you're just saying create a blank, it doesn't say what answer there is for it. And answers are tied to blanks using the ANS command for answer, and you can use the math object to create an answer checker that gets passed to this. And you can do all the fancy things we talked about with answer checkers by passing parameters to those if you need to alter their functions. But these are attached to the answer blanks in order. So the first answer blank gets attached to the first answer checker, and the second answer blank gets attached to the second answer checker. There are ways of naming the answer blanks and attaching them in other ways, but I don't want you to get bogged down with the traditional problem approach. I just want to give you the basics for this. Most problems work in this way. So that now ties answers to answer blanks. And that pretty much covers what we need in order to get these two sections for traditional problems. And it's in these sections, not in the setup or in the context or in the math objects themselves. It's simply in how do you get the output to the student and how do you attach the answers to that output. That's different from how you do it in PGML. And in the traditional problems, you will frequently have these begin text strings and end of text strings, begin text, end text, and inside of there you've got things like par and br, you've got LaTeX style math delimiters, and you have command substitution with those brackets, and frequently the command is answer rule. The other kinds of commands you get are things for lists, things for tables, and stuff like that.